Okay, here's two questions that deal with Dalton's law of partial pressures. So the first question says you have a mixture of 2 moles, 3 moles, 4 moles, 4 moles, and 5 moles. And they all exert a pressure of 800. But you have to know sort of how much each one is exerting, right? The partial pressure. But what you can do is you can add these moles up. So 2 and 3 is 5, and 4 is 9, and 5 is 14. So there's 14 moles total exerting 800 torr of pressure. So you want to know how much each one is exerting of that. Well, hydrogen is exerting 2 out of those 14. So you can say 2/14 of mole, this is for hydrogen, and then if you multiply by the total, it'll give you what portion is due to hydrogen. So let me do that on calculator. Sec. Sorry. Hopefully you can still see that. So 2 divided 14 times 800. Whoops. There we go. 114.29. 114.29. 0.29, and that would be torr. And I guess we're rounding it to 3 sig figs, so we call 114. And then ammonia would be 3 out of the 14 times 800. Multiply, and it'll give you the next number. Okay, that's how you can do that one. The next question says you've got a mixture of gases, and they want to know the partial pressure of each gas. So they tell us that I've got my volume is 10 liters, temperature is 40. And so I need to find the partial pressure of each gas. I'll do the first one, then you can do the other ones. I did give in the answer, I gave the total, but that's just all these added up. But the question only asks for each one separately. Let's start with nitrogen. So nitrogen, I have 2.14 grams of that stuff. 14 grams. So I want to know what pressure it's exerting. So I think the formula that I'll use is PV equals nRT, because I can determine pressure as long as I know the volume. I have a volume, yep. As long as I know the moles. I don't have moles, but I have grams from which I can get moles. I know R always, and I know the temperature. I'll have to add 273.15 to that. So what's that? 313.15. So I can find pressure. So pressure is nRT over V. So number of moles, I don't have that. So let me go over here and I'll do moles. So moles are equal to mass over molar mass. The mass is 2.14 grams divided by the molar mass of nitrogen. So molar mass of nitrogen right there is 1401, but there's 2 of them, and so it's 14.01 times 2, so that'd be 28.02. So 28.02 grams per mole. Calculator. So what was it? 2.14. 2.14 divided by 28.02. Okay, so I have 0.076, call it for now. 0.076 moles. 0.076 moles of nitrogen. Okay, so here's my formula. Moles, 0.076 moles are 8.314 kilopascal liters per Kelvin mole. Temperature was 313.15 Kelvin, and the volume is 10 liters. Okay, so now I can multiply that out. I have my moles here already, so I'll just leave that where it's at. So that times 8.314 times 313.15. I'm going to close the bracket on the top and hit divide, and I'm dividing this by 10. Okay, so the pressure exerted, partial pressure due to nitrogen, will be 19.884. Okay, moles cancel, kelvins cancel. This is liters, liters cancel, kilopascals. Let's check, and looks like I have 3 sig figs everywhere, so I'll need to convert that to 3 sig figs. 19.9 kilopascals. That's the first one. And then you do the same thing for the others. All right, hopefully that helps you answer those 2 questions.